Okay, so in this video we discuss tutorial question, and we're gonna start with the objective question. Question number 1, which of the following statement about the motion of charged particle entering a uniform magnetic field is not true? So the one that is incorrect. So it says the path of the particle is parabolic if the direction of motion is parallel to the direction of magnetic field. So it says that direction is parallel to the magnetic field, maybe same direction. Magnetic field in this direction, let's say, and you have a particle, maybe a positive charge moving to the right. This is your V and this is your B. So if you want to find the force is equal to QVB sine theta, right? So if the theta V and B is in the same direction, that means theta is equals to 0. So if theta is equals to 0, then your F is equals to 0. That means there's no force acting on the particle. So as a result, it will start to move in the same direction. So it wouldn't move in the parabolic lah. It will start to move in same direction. So the answer is A. Question answer B, let's just check this one. The path of the particle is circular if the direction of motion is perpendicular to the direction of the magnetic field. Okay, this one is correct. You can imagine that this one as if it is spectrometer. So you have magnetic field going into the page. Okay, and then let's say the positive charge, into the page. Okay, let's say the positive charge is over here. Okay, initially it is moving to the right, and you can try to do right hand palm rule. You can see that the force is actually going upwards, and then as a result it start to move in circular circular motion. So answer B is correct. The magnitude of the magnetic force is directly proportional to the charge of the particle. That one is correct as well, since F equals to QVB. So F is directly proportional to the Q. The magnitude of the magnetic force is maximum if the direction of motion is perpendicular to the direction of magnetic field. This one is correct as well. That means your theta is equals to 90 degrees if it is perpendicular. So sine 90 is equals to 1. So this one is maximum when this part is equals to 1. So the answer is A. Question number 2, a proton enters perpendicularly into a uniform electric field, and another proton enters perpendicularly into a uniform magnetic field. One is electric field, another one is magnetic field. How is the force on each proton influenced by the speed of the proton? Okay, you know that force for inside a magnetic field, it is actually equal to QVB sine theta. So obviously it is directly proportional to the V. Okay, so the answer is either A or C lah. But then inside the electric field, if you guys still remember, F is equals to QE. So it depends on the charge and it depends on the electric field. So it does not influence by the V. So the answer here will be cat C. Question number 3, the magnetic flux density at the end of a long straight current carrying solenoid is B. What is the magnetic flux inside the solenoid? So you know that if you want to calculate solenoid, outside here is equals to half from compared to the inside. So you have a formula of mu naught Ni over L. This one is for the center. At the end, this one becomes half. So given that at the end there is equals to B, that means that the center is double to that value, so it becomes 2B. Okay, question number 4, a coil of wire carries a current I as shown in figure 4.1. If the observer could see the magnetic field inside this arrangement of loop, how would it appear? So you have to use right hand grid rule. So basically you want to put your thumb in that direction, right? And then all your fingers will be in that direction. because the current is going upwards. So you can see that the magnetic field is actually moving to the left in this case. Like that. And since you are looking from this part, so you see that it is as if it is going into the page. So the answer is C lah. Okay. So I just want to show you. So this one is the same case. Okay. Oops. So this is how you want to apply the right hand grip rule. Basically, you want to put your thumb to be in the same direction as your you want to put your fingers in the same direction of your current, like this one. So put it like this, and the thumb will be the direction of the field. So the answer is C. Excuse me. In question number 5, a long straight wire carries a current I. If the magnetic field at a distance d from the wire has a magnitude B, what is the magnitude of the magnetic field at a distance 2d from the wire? Okay, you want to use a formula of B equals to mu naught I over 2 pi r. Okay, for the first part, it says that this one is 2 pi d, right? Distance d. And then the question wanted to find what if the distance now becomes 2d. So nu b is mu naught I over 2 pi 2d. So if I factorize the 2 there, or half, so I got 1 over 2. And this thing is actually equals to the b. So your answer would be A or B. So both answers are correct. Same answer. Okay. That's it for this video. Thank you. Okay, next question is question number 8. Question number 8b. The figure shows an electron particle moving with velocity of 450 meter per second. Enter perpendicularly into a uniform magnetic field of 2.5 Tesla as figure 4.3. What is the magnitude and direction of the magnetic field force on the particle? Describe the path inside the particle. Inside the field. So if you want to calculate the magnitude and the direction of force, you can use F is equals to Q V B sine theta. This one involving electron, so the charge will be equals to 1.6 times 10 negative 19. Maybe I do it down there. Okay, and then the velocity here is 450 given in the question. And the values for B is 2.5. Again given in the question. The angle here represents the angle between V and B. So if the electrons is over here, okay, the magnetic field is going out of the page, and then magnetic field is into the page, and then the velocity, let's say this one to the right, so you can expect that it is 90 degrees. So sine 90 is equals to 1. Okay, and then you press the remainings, should get 1.8 times 10 negative 16 Newton. And then it asks you to determine the direction of force. Okay, you have to use right hand palm rule. So this is my hand. The thumb represents the direction of velocity V. Force, magnetic field first. Magnetic field is into the page, so this one is into the page. All the fingers are pointing to the page. And the force itself, since this one is electron, so you have to back slap the hand. So this is the direction of force. So you can answer downwards. Okay, so you can imagine that this one, because this one is moving downwards over there, so we start to produce a circular motion over there. So over there is downwards. Okay, over here it will be to the left, right, using this hand. Magnetic field stay into the page, back slap, so force is to the left, and then start moving in this direction. So over there, oops, okay, over there, velocity is to the left, magnetic field into the page, so the force is upwards. Okay, so at that particular moment, the moment is enter, the direction of force would be downwards. Eventually it start to create a circular motion. Electron moves in clockwise circular motion. Okay.